Hello everyone. In previous video we have discussed about Doppler effect. When the source is in motion, observer is at rest. In case of source moving towards an observer and away from the observer, as well as the observer is in motion and source is at rest when the observer moving towards the source and away from the source. The equations for the apparent wavelength and apparent frequency we have derived. Next, and also method 1 and method 2 also we have discussed earlier. In old textbooks we have the method number 1, and for the new textbooks we have method number 2. Now today we are going to discuss about that when the both means source and observer both are in motion. And the source and observer both are in motion. If in case of when the source and observer both are in motion, when that medium is at constant, medium taken as constant, then we can get it both source and observer is in motion when the moving in the same direction, means when the observer is moving on the one direction, then the source is following the observer, then means the both source and observer are moving in the same direction, because of source is moving, so that's why we have that source velocity Vs, and observer is also moving in this direction, so that's why we are taking that V0 be the observer's velocity. Then the apparent wavelength, all we know that lambda dash is the apparent wavelength is equal to, then wavelength is equal to V by nu, means velocity by frequency. So that's why velocity will be here V minus Vs be the velocity, and by nu is the frequency. Means whenever the lambda dash means apparent wavelength lambda dash is equal to V minus Vs by nu, means frequency. Then if in case of apparent frequency, then we can get nu dash is equal to V minus V0 by V minus Vs into nu be the formula for when the both source and observer are moving in the same direction, either source following the observer, means source behind the observer. If in case of source is moving forward and observer is following, means observer is behind the source, then here we can get that here the observer's direction is changes. Observer direction changes. So here it is V, when observer behind the source, means source is traveling in this direction and observer is traveling in this direction, means observer is behind the source. Then we can get apparent wavelength lambda dash is equal to V plus V0 by nu. Then the apparent frequency will be nu dash is equal to V plus V0 by V minus Vs into nu. Nu be the actual frequency and nu dash be the apparent frequency here. Nu plus V0 by V minus Vs into nu, means nu dash is the apparent frequency, nu is the actual frequency. Here then next, when both are moving each other, means when the source and observer are moving towards to each other, means the distance wavelength is decreasing between the source and observer, then we can get that when the source is moving in this direction with velocity source velocity Vs, and observer is also moving in this opposite to the, means both are opposite to each other, moving towards each other, that is V0 with the observer's velocity V0, then the apparent wavelength will be lambda dash is equal to V minus Vs by nu, then here the apparent frequency will be nu dash is equal to V plus V0 by V minus Vs into nu. Then this will be the equation for when apparent frequency when the source and observer moving towards to each other, means meeting each other, then the more frequency can get by the observer than the whenever. If the source and observer are moving away from each other, then we can get it when the source is moving in this direction, that is Vs with velocity Vs, then observer is also moving in this opposite direction to the source, then V0 be the observer's velocity, then the apparent wavelength lambda dash is equal to V plus Vs by nu, then the apparent frequency nu dash is equal to V minus Va0 by V plus Vs into nu. Then here is that, then we can follow that whenever the observer or source in motion, how we get that equation directly. If we want to confirm that the equation we have derived is perfect or not, then the general equation for apparent frequency of a wave when the both source is in motion or observer is at rest, or observer is in motion, source at rest, if the both are is in motion, these are the general expression for the apparent frequency. Next, now we know the what is the general expression for the apparent frequency of a wave. The general expression for the Doppler effect in all the cases when the source is at rest and observer is in motion, or observer is at rest, source is in motion, whatever, when the source, both source and observer are in motion, both are is in motion, then we can derive the equations directly by using this equation for apparent frequency. So here is that in all the cases by applying the sign convention, means when the direction of the sound taken as a reference, then by the taking the sound as a reference, direction of sound of reference, if the sign convention is applied in the equation, then we can find the equation easily. So here is that all the cases of Doppler effect can be obtained from the general expression by applying sign convention. The general expression is nu dash is equal to V minus V naught by V minus Vs into nu. Means here the V is the velocity of sound and V naught be the observer velocity, and here is Vs is the source velocity, nu be the actual frequency, and nu dash be the apparent frequency. So by following the sign convention, when the direction of the sound is taken in a reference, taken as a reference, then we can find the equation. Then the equation for an apparent frequency, if source and observer's velocities are both are in the same direction as that of the sound direction, means here the sound direction is in this direction and also observer's direction is also in this direction, means V naught and Vs. Then we can take it as a positive Vs plus Vs plus V naught to substitute in the equation, means same as is equation we can get because of minus of plus minus, minus of plus minus. So V minus V naught by V minus Vs whenever the both are in having the same direction, means in case of just now we have derived an equation whenever the source is behind an observer, then we have derived an equation that is when V minus V naught by V minus Vs, means if in case of source is moving in this direction, that is positive Vs, because of sound is also in this direction, and this is the source and this is observer, the observer's velocity is also in this same direction, then both can be taken as positive. So that's why we are applying this one, V minus of plus V naught, then V minus of plus Vs, then we can get V minus V naught by V minus Vs into nu. That will be the equation for when the both source and observer is moving in the same direction, when the source behind an observer. If in case always sound travel towards the direction of the observer, as we know that. So if in case of both are in opposite direction, means the observer is behind the source. This is the observer, positive V naught, minus V naught, and the source is moving, the sound is moving in this direction, then minus Vs. Then we can get from the equation, so V plus V naught by V plus Vs, means here is minus of minus V naught, because of sound always moving towards the direction of an observer, because the observer receiving the frequency. So that's why here is the direction of V, here is also direction of V, velocity of sound. So when the sound is absorbed by an observer, the observer's velocity is in opposite direction to the velocity of a sound, then the source's velocity is also opposite direction to the velocity of sound. So that's why it is taken as a minus Vs. The observer's velocity is also taken as a minus V naught. So minus of minus V naught, minus of minus Vs. Then we can get that V plus V naught by V plus Vs, as whenever we have derived equation, that is when observer behind the source. observer behind the source, that is V plus V naught by V plus Vs, as we know that. Then next, if in case of when the source is in motion, observer is at rest. Source is in motion, observer is at rest. Means source is in motion, Vs means whenever source is moving towards an observer and observer is at rest, V naught is equal to 0. Then it is moving towards an observer, that is plus Vs. As V naught is equal to 0, then we can get nu dash is equal to, when V minus V naught is equal to V minus 0 by V minus of plus Vs. So here is that V minus Vs into nu. This is the equation for when the source moving towards the stationary observer. If in case of away from, when the source is moving away from, their sign will become minus Vs. Then means the sound velocity is in this direction, then the velocity of source is in opposite direction to the velocity of sound, then the velocity of source is negative, taken as a negative. So here is that whenever minus of minus Vs becomes plus Vs, when the source is moving away from the stationary observer, then we can get that apparent frequency nu dash is equal to V by V plus Vs. Here is that, and again we can, in all the cases we can derive an equation when the air is at constant, means medium is at constant. We should follow that one, medium is at a constant. Medium is at constant, whenever we take in that medium is at constant, then we can, all the cases we can derive the equations by using this general expression for a Doppler effect in all the cases by applying sign convention. Here is that if opposite direction of a sound taken as a negative, already we just now applied, then easily we can find it out that in 10th class, means in 10th standard we have the diagram for trigonometrical, that is all silver teacups type of diagram, all silver teacups. All silver teacups diagram. When the source taken as primary first one, then observer taken as the next one. When the source first one, after that observer taken as next one. Here is the whenever the source or observer is moving in this direction, means this is the positive x-axis. This is type where we can get the negative values of x-axis. So that's why we are taking that this is negative x-axis, this is positive x-axis. Then if the source or observer, whatever it is, if the moving in this direction means positive side, then that values can be taken as plus Vs plus V naught, means positive direction. If in case of both source velocity or observer's velocity, means in the direction of negative x-axis, then it is taken as minus Vs minus V naught. Here is the one of the trick. Then we can follow the, if we take the sound direction as a reference, then easily we can, whatever the take in the direction is there, we can find out the values easily. So we should take first the sound as the direction of sound as a reference, then we can get easily. If the sound is moving in some of the direction, sound moving in this some of the direction, means this is the direction of the sound. Here is the source or observer, here is the source or observer, whatever. Then source, observer I am taking. Then here is that the direction depends on the equation by applying sign convention. Means if in case of this is the positive, this is positive, this is positive, either they are moving in the negative, this is negative, either it is moving minus negative. Means negative means it is positive Vs, positive V naught, negative V naught, positive Vs, minus Vs. Means by total depends on this sign convention. By using this general equation, we can find it out the apparent frequency of a wave in all the cases by using this sign convention.